A warm welcome to everyone. Good afternoon, all. Thank you so much for joining our session today. We are back with our another session, which will be talking about AWS security. We do have our guest speaker for today, Aishwarya Gupta. She's working at Quantify as a cloud engineer. Before I hand it over to Aishwarya, let me talk about a quick thing. Aishwarya works as I mentioned, as a cloud engineer at Quantify. She works in and out on different AWS security tools like KMS, Config, IAM Security Hub. Those are the different things where she is an expert and a go-to person. Along with that, she also loves to do different certification, technical blogs, giving different speak at communities. That's what Aishwarya is known about. So I would request Aishwarya to go ahead, talk about herself, and take over the control. Thank you. Aishwarya, over to you.
Hey everyone, good afternoon. Thank you, Sanchit, for the warm welcome. Hi everyone, today I'll be your speaker for today's session for AWS Solutions Architect Associate Certification Bootcamp. That would be on the AWS Security Services. I will take you through the various services that AWS has provided us for managing the governance, security, and auditing of our AWS cloud. Before we jump into the agenda, I would like to talk to you about the AWS Security Shared Responsibility Model. So, let's say you, as a customer, move your application to the cloud. Your main point of concern would be the security of your application, the security of the data that is hosted along with your application, right? So, here's where the responsibility model comes in. AWS has the responsibility for the security of the cloud, right? Now, what does that mean? That means that taking responsibility of protecting the infrastructure and the software on which the cloud is hosted, as well as the various services function. While they take care of that, they also hold the client responsible for taking measures to protect their own data as well as the platform on which they have hosted their application and the host operating system on which their application and the servers run. For this security model, AWS has provided us with different services that lie into multiple subdomains. As we can see here, I can explain it to you in the next slide, right? So these are the subdomains in which our security services lie in. For example, the first one is identity and access management. This is the most basic principal security service that we need, that we will be diving into. So when you create an AWS account, you would have multiple people working on it, right? Ideally, on a project, there would be a team that works on your AWS account. So not everyone can have root access, right? So everyone needs a defined set of permissions that needs to be assigned to them, and they can only do those actions and nothing else. For example, a developer would need access to, say, AWS Lambda or AWS EC2, while a data engineer would need access to the database. That is where AWS Identity and Access Management comes in. Now, there are two other services that are in this domain, that is AWS Single Sign-On Service as well as AWS Cognito. These services would be covered in the later sessions, but let me give you a brief introduction. So, usually in large scale projects, there's not just one AWS account, there are multiple accounts that are covered in an AWS organization. IAM is account specific. It's a global service, but it's account specific. So it would be a tedious task to go into IAM for each account, and it would be hard to maintain consistency defining the same thing in each account. That's where single sign on comes in. It helps us control centrally how and what users access which account and what privileges they have. Similarly, Cognito, single sign-on and IAM are for the people who are working on the project, who are signing in into AWS. Cognito is for the people who are signing in on your application that is hosted on AWS. So these are usually for the users of your application with respect to what you have hosted on cloud, right? Next comes the detection services. the various services that we can use to detect any misbehavior that is happening inside cloud, as well as any threats that are coming from outside. So that would be AWS GuardDuty, Config, and CloudTrail. And next would be infrastructure protection. So this is basically the network of your where your project is hosted, the VPC, the security groups, the subnet. To protect this, that is perimeter security. I'm sure everyone would have heard of firewalls, right? So this would cover all the services that provide us with firewall and the different network access control lists, as well as protection against very famous attacks such as DDoS attacks or SQL injection attacks, right? Then comes the data that you have on cloud, that you've hosted on cloud, or that is streaming into your cloud. How do you protect this data? That's where the services related to cryptography come in, that is encrypting your data, so that we make sure that no one can access it. So here the services provided are AWS KMS, Cloud HSM, Certificate Manager, and Secrets Manager. All these services we will be going into much detail later in the slides. So let's start with AWS Identity and Access Management. Until now, if anyone has any questions, you can please put it on the chat and we can address them. All right, assuming there are no questions till now. So, what is identity and access management, right? So, for example, let's say until now, all the services that you've learned, right? There's an AWS account that you have where you have a region and you've created a VPC in that region. And in that region, let's say you have a database service that is RDS. You have several S3 buckets, you have some EC2 instances on which your servers are hosted, and an application load balancer from which the traffic comes in. Now, when we talk about securing this architecture, this is a sample architecture. Usually, they are much more complex than this. But let's say if you want to secure this architecture, we would usually think about firewall, right? Protecting your application from external threats. But that only covers as parameter security. What about security within your application? What about all the transactions that are happening within your VPC? How do you secure those? That's where IAM comes in. IAM makes sure to authenticate every single request that takes place inside your AWS account. IAM is a global service, so it can work for several VPCs that are hosted in your AWS cloud, but it makes sure that it authenticates and authorizes every single request that takes place inside your account. So let's move on to the overview for AWS IAM. So identity is basically like a human or a resource, right? Identity means you and me. So for example, if you want to access anything inside an AWS account, you would be referred to as an identity or a principal, which we'll understand later when we talk about policies, right? The meaning of the name principal, right? So identity and access management provides fine-grained access control across all of AWS. So uh, what IAM does is, for every request that you make, like I said previously, all your requests are filtered by the access that you are given, and they are denied or they are approved based on the policy that are attached to your user, right? So with IAM, what you can do is you can specify who, that is the principal or the identity, can access which services and which resources and under what conditions. So this basically defines the structure of a policy that will come across in the later slides. So this is basically what a policy is, right? And you manage permissions based on least privileged permissions, right? So basically, AWS has a best practice in which it asks for us to assign least privilege to each of its users. That is, we cannot just directly give administrative access to everyone, right? If someone needs to only read data from S3, then we give them only S3 read object or list object permission. We don't give them S3 colon star permission to do anything with S3. That is one of the best practices. That's where IAM comes in. IAM is completely free. So it's a free service, there is no charge, and it's a global feature, right? Moving on to the next slide. So whenever you create an AWS account, you begin with an identity that has complete access over all of your AWS resources in that account. This is called a root account, right? So AWS best practices also ask us to never use the root account credentials because it is much more than just administrative privileges. A root account user can change its own root password. A root account user can also delete an account, which is very dangerous. That's why it is recommended to never use root account credentials. So, what to use then, right? So, that's where IAM users come in. IAM user is an entity that you can create in AWS to represent a person or an application that is used to interact with AWS, right? So an IAM user can be a user or a group of users, right, to which permissions are attached. It can also be a role. For example, if a service needs to do some actions on your behalf, for example, an EC2 needs to access an S3 bucket, that's also an identity, right? So users can be like, for example, in a project you have multiple developers, you have multiple operations, that is DevOps people, you have auditors. So these users have similar tasks that they need to perform in an AWS account. So we can group them into this logical unit called a group. This group can be attached to like a single policy, right? A single access control, and all the people that are assigned to that group can have that same access. That helps us in giving access to multiple people in a project, right? So we can group them into uh, these logical units. So an IAM role is an entity that defines a set of permissions that make an AWS service request, right? So we have three types of identities, that are users, groups, and roles. What are roles? Roles are basically the same thing, but it is permissions attached to a resource rather than a person. Moving on to the next slide. So once you've created a user, how do you access the AWS account using that user, right? So that's where these various authentication methods come in. So when you create a user, you can have multiple ways you can access AWS. One is through a password, right? You can define a username and password. When you go to the AWS login console, you can log in as an IAM user. Now you can provide the username, password, and an MFA token. MFA we will discuss in later slides. There's another way that you can access an AWS account, that is using AWS CLI. So these are various command line commands that you can use to access AWS programmatically through like a terminal, right? So here a user would need to create access key and secret key credentials. Here the username and password won't work. So we need access key and secret key to be generated to access AWS using CLI. Similarly, API, what is API is a library that can be used to access AWS using different programming languages. For example, in Python, the AWS API is Boto3. Using Boto3, if you're accessing any service on AWS from your local machine, you would need access key and secret key. So when you access your AWS account using CLI and API, what IAM would do is IAM would analyze all the policies attached to the user in which you've created the access key and secret key. So before we move on to this, let me show you the same what I've discussed in the previous on the console. I hope my screen is visible. So this is the Identity and Access Management console. As you can see, we have various options here. We have users. These are the various users. We have user groups in which we can group our users. Currently, we don't have a group. And we have roles. Roles are what we can attach to a particular resource. And the smallest unit of permission here is a policy. So a policy consists of all the permissions that can be assigned. A role is what inherits these permissions from a policy. A user can also inherit these permissions from a policy, as well as a user group can also inherit these permissions. So when I open my user here, we have these various policies attached to my user. As you can see, they are represented differently. This policy and this policy are represented differently, right? We can go in detail later. So this is an AWS managed policy and this is an inline policy. Now if we go to security credentials, as you can see, I have a console password assigned to me. That is, I have access to the AWS console using this user. So I can log into AWS as an IAM user, and I can have an MFA device assigned to me. So if I go here, I can use multiple types of MFA devices, such as a virtual MFA device, an authenticator app, let's say Google Authenticator or Microsoft Authenticator, or a hardware device that can be provided by a third party, right? I can also manage my password here. So if I go here, so as you can see, I have console access. So I can physically log in into my AWS console using my IAM credentials. I can also disable this. And I have various ways to set my password. So I can use an auto-generated password or I can create a custom password. I can also select this option in which if I am signing in as a first time user and I would need to change my password. These are just various ways to secure your access to the AWS console, right? Now, access keys and secret keys. Now, if my IAM user had programmatic access to the AWS console, programmatic calls such as CLI, PowerShell, or AWS SDKs, that is using a programming language such as Java or Python to access the AWS console, then I would need to create access keys and secret keys. Using these, I would be able to programmatically access AWS. Similarly, I can, for example, let's say I create a user group. Right now, I can add users to this group that are already created, and I can attach permissions to this group. So what would happen is, apart from the permissions that I already have as a user, I would also inherit the permissions that are attached to this group. So for example, if I add my user to this group and I give myself Amazon Glacier read-only access, the user that is in this group would be able to inherit these permissions as well as the permissions that are directly attached. That is these. As you can see, I have this permission as well. So that's pretty much about IAM users and user groups. As you can see, I have defined here a password policy. So when we create an IAM user, we create a password for him, right? So we can use this password policy to increase the strength of the AWS account, so that it cannot be hacked. So it's not pretty obvious, like many people keep their password as their username. So you cannot do that here. It has to have a specific pattern, right? And you can do that here in AWS. So you can go to account settings. You can create a password policy here. So these are the options that you have, and your password should follow all these options. I can also enable password expiration such that the user would have to change the password every time it expires. This only strengthens your access. Now we come to multi-factor authentication. So, access by IAM users can be increased in strength multifold using MFA. I think everyone would know about MFA. We can add MFA to almost all of our accounts nowadays, even Gmail, Facebook, Instagram, right? So, similarly, in AWS, you can scan this QR code in your Authenticator app, and you can have an MFA assigned to your account. So every time you log in, you'll have to enter an MFA code. Now we come to IAM policy, right? So what is an IAM policy? Uh, it is a JSON based policy, right? It is a JSON. It is a very simple JSON like this. And what it defines is, uh, let's see here, who can access what and under what condition, right? When they can access, right? So basically, a policy is a JSON that is attached to either IAM identities or IAM resources. IAM identities are users or groups or accounts, and IAM resources are, for example, if there's an IAM policy attached to S3, that would be a resource-based policy. So this a policy is where you define the least privilege principle. That is, if I want to give my user only the permission to read an object from S3, then I can just define that instead of giving them the permission to do anything with an S3 bucket. I can just define that the user can only read the objects from S3. So there are three types of policies, right? Like I showed you on the console, there is an AWS managed policy. These are the policies created by AWS, keeping in mind various scenarios where you could use them. These are maintained by AWS, and these are reusable as well. Customer managed policies, for example, you have your own use case where you want to define your own set of permissions that you want to give to a user. You can define your own type of policy. These are also reusable. These can also be used in multiple roles or assigned to multiple users, right? And then there is inline policy. So inline policies are specific to a particular role, right? In a role, you can define an inline policy. Let me show you. For a given role or a user, you can have multiple inline policies, but these are only valid inside that given role, right? So I don't have one here, but I probably have one attached to my user. So these are what inline policies are. As you can see, it is defined in the same way as any other policy would be, but these are not reusable. This is only specific to this given user. Similarly, it could be created inside a role, or it could be created inside a user, right? So yeah, as I said, the difference between inline policy and managed policy is managed policies are their own resource. That is, they can be reused or attached to any number of users, groups, or roles. Whereas inline policies are directly attached to a user or a role, and they are not valid outside of that user or role. Moving to the policy structure, right? So this is what the JSON looks like of a policy. There is a version. Version basically defines the language syntax rules in which you have written a particular policy. So there is obviously a syntax in which this policy needs to be defined. So this value is always defined as 2012-10-17. This is the latest language syntax. After that, there is an ID. ID is just an identifier for your policy. Then there is statement. Statement is the main policy element. As a container, it can have multiple substatements, right? So inside a statement, this is a list as you can see, there can be multiple substatements. So the SID is a statement ID to distinguish between all your different statements. It is an optional, same as ID, it is an optional field. Now what is effect? Effect can be either allow or deny. You can either define what you want to if you want the user to never put an object in S3 bucket, you can just directly mention deny and user would be denied of putting an object. Or allow means user is only allowed to perform these two tasks. Now what is principle? Principle is the who of a policy. The principle, so like I said, there are two types of policies, right? There is a resource based policy and there's an identity based policy. Identity-based policies are attached to users, roles, or groups, and resource-based policies are attached directly to a resource, for example, an S3 bucket. So when you're defining a principle, if it's attached to a resource, then you can define it to be like a role or a user or a group, right? Or an AWS account. But when a policy is attached to one of those, then it is automatically assumed that the principal would be that given role, right? So then principal cannot be defined. For example, if I'm attaching a policy to my user Aishwarya.Gupta, then a principal cannot be defined in that policy because principal would be assumed to be my user. Similarly, moving on to actions. So actions is basically what can be done. So who can perform what action? Action is basically these granular permissions that I want to assign. So this can be either in denied state or allowed state. Then there is a which, that is a resource. So same as principle, if your policy is attached to an identity, you would need to define a resource on which resource can I perform these actions. But if a policy is attached to a role, that this is automatically assumed that, for example, if this is attached to an S3 bucket, then the resource would obviously be that particular S3 bucket. So then you don't need to define this. Then there is a when, that is a condition. So in my policy here, I don't have a condition, so I've given it here. Conditions are string regex, basically. In a given request, you would have like who is making a request to perform what action on which resource, right? So in a condition, you can have a key value pair where you can match a particular string to check even if, for example, I've allowed get object to this particular principle. I can define a condition only if user is allowed to get from this S3 bucket only if the S3 bucket prefix is chain_star. Otherwise, they won't be allowed. So condition makes our policies even more granular, right? It can be it can be made specific to a single bucket or a single bucket prefix. And the last point is not. So IAM policies have this interesting feature called adding a not version in policies. What not basically is, you can attach a not after action and make it negative, right? It's like a not gate, right? So for example, if I have the effect allow and action to be delete bucket, then I will be allowing my user to delete a bucket here, right? But if I say not action S3 delete bucket, then the user is allowed to do everything except delete a bucket. This makes, for example, if you want to give users a lot of allow permissions, right, and only a few not allowed permissions, you can use the not keyword and deny them these specific actions and allow them everything else. This would have the same effect as adding a deny in effect right here, but this is just a permutation of how you can use a negative policy. Any questions until now?
Yeah, sure. I think there is a question from
I would
Harish.
assume that to be a no. Yep.
Sorry, there is a question from Harish. Can we modify existing password policy when it will it be notified to the user that password policy has been changed after the modification?
No, I don't think the users would be notified, yes, but you would need your to change your password such that it matches the modified password policy, right?
Got it. Okay. And I think Harish is requesting again that he's unable to view the node structure. Could you please present that screen again for a
Yep,
minute?
sure. Is it visible now?
Yep. Yeah. I think we can go ahead. Thank you.
All right. So now that we've understood the structure of a policy, we need to understand which of these statements take precedence when we are when a user makes a request, right? So this is the evaluation logic. Whenever a user makes a request to AWS to access a specific resource, AWS retrieves all the policies that are attached to that user, right? So all the policies are first evaluated to check that specific action that user has requested, which of these policies have mentioned that action. So those policies are checked to see if that action is matched or the conditions are evaluated, right? Only if the conditions match, then we move to the next point. Once the conditions are matched, we check if the effect is deny or if the effect is allowed. We first check for deny. If the effect is denied, then we directly decide that the user won't be allowed to perform that specific action. And if the effect is allow, then we decide that the user is allowed to perform that particular action. The access is granted. But in case it's neither allow nor deny, the final decision is deny. This means that by default, a user has no permissions, right? If a user has no policies attached to them, by default, they are denied to perform any action on the AWS console. To give them any specific permission, we would have to attach a policy to that user or to that role. Next, we come to the IAM policy inheritance. So, let's say in your project team, you have three types of engineers, right? There are developers, there are operations, that is DevOps, and there is an audit team. Now, there are some users in each team that would require similar amount of access, right? So you create these groups, these IAM groups, and you assign these users to these groups. Now, all these users would be inheriting the policy that is attached to that group, as we saw earlier. But what about the users that are part of both of these groups, right? If Charles is a part of developers as well as audit team, what happens and what access does he get? So, for example, if developers have access to S3 to like administrative access to S3, let's say S3 colon star, and audit team only has access to list objects in S3, then Charles would be inheriting both these policies, and the highest amount of access would be applicable on Charles. So now Charles will be able to access uh, S3 administratively, right? Since between S3 read object and S3 star, it is the highest amount of access. Similarly, for David, the highest amount of access would be implemented while comparing both of these policies. An inline policy is only specific to a given user group or role that it is assigned to. So Fred is inheriting this inline policy. This inline policy is unique to this user, Fred. It cannot be reused. Now we come to IAM rules. So I've already discussed earlier, right? What is an IAM rule? It is an entity that defines a set of permissions for an AWS service to perform some actions on your behalf, right? So, for example, the most common type of IAM role is an EC2 role. For example, you have your application running on EC2 and you require to access an S3 bucket, then you attach or you require to access, say, the database. Then you attach a role to EC2 where you define that this EC2 instance can access the RDS database and an S3 bucket. That is what a role is. It's pretty simple. Now, IAM provides us with certain security tools that we can use to audit the granular access as well as the users and their credentials that are provided uh, in the tool, right? So one of the tools is IAM Access Advisor. Let me show this tool to you on console, right? So this tool comes in handy when you want to refine permissions. Like you've given a certain amount of permission to a user, but after auditing, you find out that the user does not need, for example, an S3 bucket to access S3 buckets at all. So that's what Access Advisor helps us understand, right? So if I, for example, if I go into this policy, we have a tab that says Access Advisor here, which tells me what all services have accessed this permission and when these permissions were accessed. So here you can easily identify how to refine your policy further, right? If you, for example, if let's say you are assuming that EC2 access would be required by these given services, but then you check the functionality of these services and you find out that they are never accessing EC2, then you can directly go to the policy and you can remove that. You can remove it from your the policy. You can view it in a more readable format right here. So I have uh, limited my access in a more granular level. I have not given all access to logs, it is just write access. Similarly, in S3, I've only given access to a particular resource. So it tells me that the resource are multiple and not all resources. So Access Advisor basically helps us understand the the level of access in which a particular policy is being used and by what all services a policy is being used. Similarly, I've demonstrated it here. Let's say if a policy last accessed is unknown or it is 1 year ago, you can directly go ahead and delete that policy. Then there is another tool called IAM Credentials Report. So you can generate this credentials report and store them in S3 or you can download them. What it does, it lists down all the users in a given account and the status of their various credentials, right? So let's say you have uh, two users, then it's easy to understand what they are accessing and when they're accessing the account. But in more large scale projects, you have multiple users, say a team of uh, 50 developers, right? So you cannot go in and check on every user at a time. So you can create these credentials report at a timely basis, and you will have the following information in this credentials report, right? Just to check compliance, right? Let's say which users have MFA enabled, right? For added security, you can check which users don't have, and you can ask them to enable MFA. Then you can check if users have rotated their old access keys. It is important to rotate access keys because if someone gets hand on your access keys, then let's consider your account to be hacked, right? Therefore, it is important to rotate old access keys, delete the old ones, and create new ones. Then there are, let's say, if a user is not using their access keys at all, so you can ask them to delete their access keys. passwords can also be rotated at a periodic manner. Let's say every 3 months you need to change your password. So you can inform these users that they need to change their password, so on and so forth. So that completes what the service AWS IAM. As summary, it is very important to remember what IAM users are, what user groups are, what are policies, and what are roles. And also, let me go back to this slide. By the exam perspective, it is very important to understand the various authentication methods in which you can access the AWS console, right? You given a user how you can access the services inside a console. So, any questions on IAM until now? All right, I'll go ahead. So, after you have authenticated all the requests that are happening within your AWS account, what about, like, let's say, right, the data that you have hosted in your AWS account, right? What about the security of that data? How like IAM does not look into how your data is protected, who is accessing your data, right? It just allows certain users to perform certain actions. So what about the data that you have in S3 or in an EBS volume that is attached to your EC2 instance? So AWS provides certain cryptographic services that allow you to encrypt your data in various states, namely at rest and in transit, such that even if anyone is able to access that data, they cannot decode it. It cannot be useful. So let's say you can use a KMS service now to encrypt your S3 buckets as well as your EBS volume that is attached to your backend server. Even RDS internally uses encryption to encrypt the data, right? But this KMS only talks about data that is at rest, that is stored in an S3 bucket, that is stored in an ABS volume. What about data in transit? That is coming from the outside inside your application. How to secure that data? That's where SSL certificates come in. SSL or TLS certificates. This is created using a service called a certificate manager that we'll be covering later. So now using this SSL certificate attached to your load balancer, you will be able to encrypt that data that is in transit coming from outside into your application service. Talking about AWS cryptographic services, right? All these services have a principal root of Cloud HSM. What Cloud HSM is, it is a service for creating and managing cloud-based hardware security modules. What hardware security modules do is they maintain and govern keys. These keys are used to encrypt and decrypt our data. So all these services at their root use HSM, right? The HSM service. But here, the difference between these services is what is managed by AWS and what is managed by you. So towards the left of this diagram, uh, almost everything is managed by AWS using KMS, and it provides you a very simple API where only at click of a few buttons you can encrypt your data in almost any service, just selecting a checkbox, as I'll show you later in this demo. You can just encrypt your data directly. This API can be used with, let's say, S3 or EBS. And there are various types of keys that you can use. Even AWS even manages those keys, so you won't have to worry about the management or the rotation of keys as well. Then there comes a certificate manager. Here also, HSM is managed by AWS. Then there is Secrets Manager, where you store your secrets, for example, database passwords, database username, stuff like that. There also the HSM, the Hardware Security Module, is managed by AWS. And lastly, we have Cloud HSM, right? So for users using legacy systems or using having compliance to use a specific type of key that is not provided by KMS, they are forced to use their own cloud HSM service, hosting their own hardware security module on AWS within the VPC, where they have complete control over the encryption keys to generation, the management, the rotation, etc. So let's start with AWS key management system, right? So anytime in AWS we talk about encryption of data, we talk about KMS, right? What KMS basically, let's say what encryption basically is, right? There's some data that you want to encrypt. So you use a plain text data key, you use an algorithm, and you encrypt that data. This since this key is used to encrypt the data, it's called a data key, right? Now what if I want to encrypt this key as well? So when I encrypt this key, uh, it becomes an encrypted key, and it is also stored with that data. The key used to encrypt the data key is called a customer master key, that is a CMK. Now like here you can see I have used a data key to encrypt my plain text data, and I have used a master key to encrypt my data key, and both are stored together. So this is what a customer master key is, and that is the basic unit of KMS. This is what KMS manages, right? So KMS is an easy way to control access to your data, and AWS manages this CMKs for us. It is fully integrated with IAM, so you have to define an IAM policy attached to that key to authorize users to use those keys. KMS makes it easy for us to manage cryptographic keys. That is, all the burden of operations is taken away from us since it's a managed service, and it can be used with multiple services, like I mentioned before. It is also integrated with CloudTrail, right? So we can check who accessed which key to decrypt or encrypt what. So this is about customer managed keys. As I mentioned before, one of the limitations of KMS that it can be used to encrypt or decrypt data only up to 4 KB in size. After this, we would have to use custom keys, right? So now there are two types of encryptions. So there is symmetric and asymmetric. AWS recommends that we use symmetric keys, and most of the AWS services support symmetric encryption only. So I'll present to you diagrammatically what symmetric and asymmetric is, right? So a symmetric key encryption is basically there's a single key that is used to encrypt as well as decrypt our data. This key cannot be accessed outside KMS, and we would need to call KMS API to access this key. And this key will always be encrypted. Whereas in asymmetric encryption, there are two different keys. There's a public key that can be used only for encryption, and there's a private key that can be used for decryption. Public key can be downloaded and distributed, right? But private key can only be accessed using the KMS API, and it is always in an encrypted format. So similarly, the asymmetric keys are used to either encrypt or decrypt, or are used to sign and verify operations. And the public key is downloadable. So where do we use asymmetric keys? Since all AWS services only provide support for symmetric keys, where can we use asymmetric keys? So asymmetric keys come in handy when a user has to send out data to AWS but does not have access to the KMS API. So using a public key that is downloadable, they can encrypt their data and send it to AWS. Now, there are different types of customer master keys. Before I move on to this topic, are there any questions? All right. So, as I mentioned before, all the KMS keys that we create are customer managed keys. So, difference between this and CMK is basically customer managed keys are customer managed custom master keys, right? So, don't get confused between customer managed and CMK. There are two different things. All the keys inside KMS are CMKs, and they can be AWS managed keys or they can be customer managed keys. So AWS services use KMS to encrypt or decrypt data that is present in your resources, right? So there are three types of keys. There are customer managed keys. On the KMS console, let me demonstrate it to you. We have three options. There is AWS managed keys, there are customer managed keys, and there are custom key stores. So AWS managed keys can basically be recognized by this naming convention. They will always have an AWS slash and the name of the service that they are attached to. So these are all managed by AWS. We can view these keys, but we cannot delete them, right? They similarly have a key policy and a configuration for encryption. As I said, all AWS services use a symmetric key type, right? And all the keys are region specific. So a key can be used in a particular region only. So this is what an AWS managed key look like. There's a customer managed key as well. So I can create my own keys here. If I want to, I can create my own key. It can be symmetric or asymmetric, right? And key material origin is if I want KMS to use its own algorithm to create a key, if I want to use Cloud HSM to create my key, or a third party tool. And regionality, we can have a single region key, we can also have a multi region key. Here we can define an alias. So here, like AWS managed keys, we don't have to follow a convention. It can be any name, description, and tags. Let's say now, when we are defining a key, we have to define these particular permissions. So, as we previously said, KMS is integrated with IAM, right? So, here we have to define the administrator. So, who has administrative access over this key? So, I can attach multiple users or roles as administrators to this key. For example, let's say I have administrative access and admins are allowed to delete this key. Then we can define usage permissions. So what all users or roles can use these keys to encrypt or decrypt data. Here also I can define, let's say I choose myself and I choose this user. Here I have an option to specify an account that can use this key. So even different account or an account different from this can use this particular key. Usually in AWS organizations, we have something called log aggregation, right? If I am collecting logs from multiple accounts in a single account, I would need to decrypt those logs that are coming from other accounts and then encrypt them again in my root account where those logs are being aggregated. That is where we can give other accounts access to our key here to decrypt the data. So this is my key configuration. This is the key policy. So those two options that we selected, right? administrator and user. They are both defined here. As you can see, administrator is my role. So these are the actions an administrator can perform. They can even delete a key, like I explicitly mentioned. And these are the users of the key. So these two people can use this key. So they have obviously less privilege than the administrator. So that's how we can create a customer managed key. There, as you can see, there's already a customer managed key here. This is also a single region key, right? So that's the difference between customer managed and AWS managed keys. The AWS managed keys are managed by AWS. The user cannot manage these keys, and they can only be used for a single AWS account. Now, what are AWS owned keys? So many services intrinsically use the KMS service to encrypt the data that is stored inside them. There, you don't have to explicitly add a KMS key. AWS directly uses KMS keys to encrypt the data in those services. So here we cannot view these keys or we cannot even manage these keys. These are owned by AWS and these are managed by AWS as well. And coming to automatic rotation, so managed keys are rotated every 3 years, and this is managed by AWS. Whereas customer managed keys, we have to rotate our keys every 1 year, and this has to be managed by us. Key policies, as I showed you previously, there can be a default policy. This is created if you don't specify anything in those admin and those user sections, right? This gives complete access to the root account, in which that is the entire account where the KMS key is located, and gives access to the IAM policies of the KMS key. And if you define your own policy, like I did so the policy would consist of the users and roles that can access it, the users who can administer the key, and also we can add an account for cross-account access. Now, coming to rotation, as we saw previously, the AWS managed keys get automatically rotated, right? So what happens is the automatic rotations that happen every 1 year. So what happens is the ID of the key, that is the CMK ID, remains the same, but the key that is used in the backend changes. So basically, if you're using the KMS API to encrypt and decrypt your data, you wouldn't have to change anything. The same procedure can be followed, and this rotation can be handled by AWS automatically. The previous key is kept to decrypt any old data that is there. So this key is kept by AWS to decrypt any old data, and once that stops existing, this key is removed, and the new key is now used to decrypt and encrypt our data. When it comes to customer managed keys, we would have to manually do the key rotation, right? So what we'd have to do is the main difference between manual rotation and automatic rotation is the key ID would change. When you create a new key, the ID of the key would change. Therefore, we would have to make changes in our code if we are programmatically using KMS to encrypt and decrypt our data. We would have to update the key ID. Therefore, it is better to use aliases in this case. Key aliases is basically the name of the key. So we can keep the alias of the new key and the old key as same, and therefore it would be easier to reference both the keys. Once the KMS key is scheduled for deletion, the like the code would automatically start pointing to the new key that was created with the given alias name. Coming to the difference between KMS and Cloud HSM, like I previously mentioned, the Cloud HSM or the hardware security model is a tool that generates and stores the cryptographic keys, right? It is the base of all of these cryptographic AWS services, KMS, Secrets Manager, Encryption Services, ECM, and Cloud HSM. The difference is when we use Cloud HSM, we want to take complete control of the hardware security module, and we don't want AWS to maintain it. We maintain it, we define the algorithm for it, we define the rotation, etc. Right? So, Cloud HSM is a service for creating and managing cloud based hardware security modules. These can be created within our VPC where we have all our resources and can be hosted on EC2 instances. So, let's say if a user has a legacy system that needs FIPS level 3 algorithms, then they would be forced to use a Cloud HSM service for encryption keys. Because or if there's an algorithm that is not provided by KMS, then they would have to use Cloud HSM. Coming to AWS Certificate Manager, so as we previously discussed, right, KMS only takes care of data that is at rest, that is stored somewhere in a specific service. But what about data that is flowing in our application? How do we encrypt that? How do we make sure that it cannot be accessed by anyone on the outside? That is where Certificate Manager comes in, right? So what Certificate Manager does is there is two types of certificates, right? There's a secure socket layer certificate, and a newer version of it is a transport layer security certificate. So, what this does is this helps us encrypt the data that is coming into our application, that is coming into our application using a load balancer or a CloudFront distribution or even an API gateway, right? So with Certificate Manager, we can create, we can provision like a free public certificate or a private certificate for internal resources, right? For example, if you have an internal API gateway, we can create a private certificate, and for external resources, that is internet facing resources, we can have a free public certificate and deploy it on an AWS resource. This so what is the advantage of certificate manager is that it automatically handles the renewal of certificates. After every year they are automatically renewed, right? Once we attach it to elastic load balancer or a CloudFront distribution, we just have to forget about it. It is automatically renewed and managed by Certificate Manager. Any questions on all the cryptographic services of AWS? Let me quickly show you Certificate Manager on console. So like you can see here, there's a certificate. It is attached to a particular domain name, right? You can attach a number of domain names, and it is issued by Amazon. So this one is attached to a particular domain name. And here we can see the information about the certificate. It is an SSA 256 algorithm that the certificate is using and can be used by CloudFront, load balancers, or API gateway. Here we can see when it was issued, when it will expire, and when it is eligible for renewal. This certificate is attached to a CloudFront distribution currently. Similarly, I can go ahead and request a certificate. It can be a public certificate or a private certificate, right? Let's just say I want to create a public certificate. Here I can define the domain names to which the certificate is attached to, and the validation. So it can be email validation. So our DNS validation. DNS validation is recommended since here you are defining the domain names. You can authorize or modify the DNS configuration of your domains in your certificate request. and I can request this. So once the domain validation is completed, the certificate would be ready to use, and then I can attach it to my respective load balancer or CloudFront distribution. Any questions on certificate manager?
Yeah, I think there's one question from Harish. What do you mean by signature algorithm?
On high level, let's say you are using these services to encrypt your data, right? So basically, these algorithms are used to define the way in which your data is encrypted. Let me see if I've covered all the points. All right. So I hope that answers your question.
Yes, yeah,
All
I think
right.
I should.
After we're done with the cryptographic services, right now all our requests are authenticated, all our data is encrypted at rest as well as in transit. Now, what about, let's say, even if the actions are authorized, there are certain sets of rules that we need to follow. There is a compliance that we need to stick to when we are creating a project, right? Now, how like compliance is a full time thing, right? You need to be aware from day one if all the resources that are configured in your AWS account are following those specific set of rules that were issued to you. And it is a continuous monitoring of resources. And when there are multiple resources in your account, you cannot go and check the logs or the metrics for each resource or the configuration, especially when there are multiple people working. So that's where AWS config comes in, right? So AWS config continuously monitors each and every service in your AWS account for any configuration changes. So let's say someone in your account set an S3 bucket to be publicly readable, and they also opened the SSH port of an EC2 instance to the public, right? Now, what would happen is the AWS config would detect these two following non-compliant resources. It will send you a notification saying something is wrong, right? It would give you the entire, not just something is wrong, they will give you an entire JSON saying what resource and what is the non-compliance that happened. So given if you've attached a particular rule to AWS config, it will tell you that the CC2 is non-compliant to this given rule. Then AWS config has even the capability of remediating this. So it can go ahead and remediate the S3 bucket set to public. It can make it private. It can go ahead and close that SSH port. Then it can inform you that everything is good now. So that's just a high level overview of what config does. Let's dive into the service. Like I said, uh, different projects have different set of rules that they need to adhere to when they are being generated, and it is a process from day one. You always need to be ready for audit, right? So the first point is to reduce the load of operations on the various administrators and developers. We need a compliance engine that can help us in being ready for audit at any point of time. So AWS config is a service that enables you to access uh, and assess the access and audit the various configurations and evaluate the same of the different AWS resources in your account. Config continuously monitors and records the configuration changes of each and every AWS resource and allows you to automate remediation actions and even notifications if there's any non-compliant resource that is detected, right? So AWS config is integrated with CloudWatch events. So it sends events to CloudWatch that we can easily detect and that could trigger a Lambda function to remediate. So with AWS config, what are the use cases that we would use it in, right? So what are the configurations that we would want to monitor? For example, like I said, if there's an SSH port in your EC2 that is open to everyone on the internet, that could lead to potentially an attack, right? So we would want to monitor if there's an unrestricted SSH port or any unrestricted port on your EC2 instance. We would monitor which bucket in your account is publicly accessible. We would monitor if your load balancer configurations have changed over time, etc. With config, what we can do is, as you can see in the given diagram, right? You can review the configuration changes. You can deep dive into the history of configuration changes for a given resource. You can determine if the resource is compliant or not based on the rules, the config rules that you have specified. We'll come to that in the next slide. And this resource helps us simplify the auditing and the compliance of our project. So what are config rules? These can be AWS managed rules, right? AWS has defined some rules for us, some very popular use cases that would, like I mentioned here, right, these use cases. There are already defined rules by AWS that we can directly attach to our AWS config, and it helps it recognize all the compliant and non-compliant resources in a given account. For example, if these these rules can also be customized, right? Like if there are not a very popular use case, for example, in your project, it needs to be that an ABS disk needs to be a GP2 type, or your EC2 instances can only be T2 micro. They cannot be medium or large, and they cannot be any other type but T2. Then you can create these rules using AWS Lambda to monitor the configuration of your AWS account. Whenever the rules are evaluated, we can either evaluate these rules at a periodic basis, right? For example, your account is scanned every 24 hours. And these rules can also be triggered if there's a configuration change, right? If any resource has a configuration change, the config would do an immediate scan on all the resources and identify if they are compliant or not. For pricing, it does not have a free tier. You can go in detail for each service in the pricing. Since I won't be covering this, you can understand the pricing of each service in the documentation. Coming to config rule remediations, right? There are two ways where you can configure remediations. One is using the rules, the AWS managed rules in config itself, which we will see in just a second in the demo after this. Or we can use CloudWatch events to trigger our custom defined Lambda to remediate our actions. So for example, if config detects something is non-compliant, this is an event that is sent out to CloudWatch that would in turn trigger our auto remediation action. That can be either a Lambda function or it can be directly defined using an SSM document. Config rule notifications, right? So in config, there are two ways that you can send out notifications as well. You can directly attach an SNS topic to your AWS config. So it keeps on sending you notifications of whether, of various actions that config performs, right? Like config discovered this new resource, config scanned all the resources and everything seems to be compliant, or it can give you a notification for a non-compliant resource. or you can specify what notifications you want, right? In that case, you can use a custom lambda function that sends out notifications to you only in case there's a non-compliant resource. For example, here you only get a notification for non-compliant resource, whereas here all the events that happen in AWS config are sent out in SNS and the administrator is notified. So I'll show this to you quickly on the console. So this is the AWS config console. Just 1 second. Right, currently I have 2 rules and I have 1 compliant resource and no non-compliant resource. This is the dashboard. This is the service that I'm monitoring. So I can choose to monitor a particular service or I can choose to monitor all services. I can even define a particular name of a service that I want to monitor. So I've just restricted my rule here to only 1 resource, 1 bucket. Let's see how do we do that. So here in settings, I'll turn on the recording for the demo. So now AWS config would be recording the configuration changes in my AWS account. In general settings, we can see resource types to record, right? So either we can record all the resources in this given region or we can record a specific resource. So I've selected a specific resource and I've defined the category, that is an AWS S3 bucket. I can define multiple. So I can also define a resource category or I can define a resource type, right? So if I want, I can audit regional roles also, or I can audit EC2 instances also here if I want to audit. Then there is the data retention period, right? So config maintains its configuration records in an S3 bucket. So if we can choose if we want to retain them for either 7 years or a custom period, and the minimum amount of days that we can retain them is 30, and it can extend to 7 years. Now a role that we attach to AWS config. So config needs some base permissions, right? For example, to write to that S3 bucket, the configuration history, as well as to write to CloudWatch the events. So I've attached a role here. I've created a role and I've attached it to this. And delivery method, right? So I said config generates configuration history. So I've chosen an existing bucket and I'm storing my configuration in this bucket. I can define a prefix here as well. So talking about this, right? So a direct notification of all events. So if I select this option here, Amazon SNS topic. So all configuration changes would be streamed to this SNS topic here that I select. But if I do not choose this option here and I create my alerts directly from that lambda function, that I can restrict my alerts to only non-compliance type, right? So I'll go ahead and save this configuration. So now recording is on for S3 bucket. Now I'll go to my rules. These are the AWS managed rules that I've defined. I can add a new rule. So I have an option to either add an AWS managed rule or a custom Lambda rule. These are the multiple AWS managed rules that I can select. They've covered every possible use case that could possibly go wrong in configuration, right? Like, for example, if WAF is enabled or not. If I just talk about S3, there are multiple rules. So if there is account level public block on S3, if there's a bucket blacklist action, if there is logging enabled, or if there is encryption enabled, we can check all this using these managed rules. So currently, I have defined 2 rules, S3 public read prohibited and public write prohibited. And currently all the resources are compliant. So if I go into the read rule. You can see trigger type, right? So this rule is scans all my resources either when there is a configuration change, and it also scans it periodically. So I've chosen a period of 1 day, like 24 hours. And scope of changes means configuration changes. So if there's any change, or if there's a change in a particular resource, or if there's a change based on tag, if only a resource with this particular tag is changed, only then this config rule is triggered. So what I've done is I've selected only when S3 configuration is changed, and I've also given a resource identifier so that only if this bucket has any configuration change, then this rule will be triggered. The frequency of periodic run is 24 hours. So we can change here, and we can assign some key values. So this is what my rule is. Now I will try to trigger this rule. So I'll go to my S3 bucket. This is my S3 bucket. This is also the bucket where I'm storing my config logs. So this would contain all the logs for this particular region, right? I can go to that particular date and I can check the config history. So these are all the logs. Now let me go to my bucket. And let me go to properties, permissions, and remove public access block. So once I remove this block, just removing this block would not make my bucket public. I would have to explicitly define it in the bucket ACL. So this is the bucket ACL. Currently public access has not been granted. So I will go here and I will give list and read access to public. So now as the console prompts, it is a publicly accessible bucket and public, more specifically speaking, publicly readable bucket, not right? So this should now trigger one of these rules. That is the read rule, and this should be showing as non-compliant. Now let's give it a few seconds. Meanwhile, I can show you the Lambda functions that I've created. It's a very simple Lambda function using Python and Boto3. So this is what a sample CloudWatch event looks like, right? If there's a non-compliant resource, this is an event that config creates in CloudWatch. So basically, this event, as you can see, has a source of AWS config, and the detail is config rules compliance change. Here we can also see the config rule name that has change in compliance. So this is read prohibited rule, and we can see which the ARN of the rule as well as the resource ID of which resource is non-compliant now. So here it tells me the name of my bucket, the type of resource it is, and the type of config rule to which it is not compliant, right? And I get an annotation that this S3 bucket ACL allows public read access. So I can easily manipulate this event that is created by config to remediate this public read access and set my bucket to like not have read access, right? So in my Lambda function, what I've done is, let me zoom in. Here what I've done is I have defined the different annotations. So it can either be it allows read access, it can be it the policy allows read access or the bucket ACL allows read access, right? Or it can be a combination of both of these. So what we do is, in the Lambda handler, once we get this event, the event that I previously showed you, we extract the following values. We extract the bucket name that is non-compliant, and we check what is the compliant failure. If it is an ACL failure, if it is a policy failure, or if it is a combo failure, right? In case it is an ACL failure, we notify the user, and then we go to that particular S3 bucket and we put the bucket ACL as private. That remediates our non-compliance, right? And it notifies us that the remediation is complete. If there's a policy change, then this bucket just notifies us because the policy needs to be changed manually. So let's see in config. Take a few minutes. By the time this is generated, we can check our event rule that we have created, right? So I've created this event rule. What happens is, this event rule uses a particular pattern to parse that event that config created and only trigger the lambda if we have a non-compliant event, right? If the event has this keyword non-compliant under compliance type, then this event would trigger my lambda to send out a notification and create a remediation action. As you can see, the target is our lambda function. Yeah. So here Lambda has generated this alert using an SNS topic. I've gotten this alert that I've allowed read access, right? I can directly go to this URI, see this says that all users are now allowed read access, right? All users are allowed read access. So here we can read this as a potential ACL compliance violation. After our lambda function notifies us of this, we can check the logs. It has already carried out the config remediation action. That's why we cannot see it in config. Latest log stream. Here we can see this is the event that was generated by config. It says the remediation was triggered on this particular bucket. This bucket name was again extracted from this event. It says this resource ID, and it says the remediation was complete. So now if I go to my bucket, previously as you can see I had allowed public read access. If I refresh this, my lambda function has now remediated my access control list, and now read access has been denied. This does not change this option, but as I said, just turning this off does not mean we are allowing public read access. It just says that we can allow public read access. So now this bucket is again compliant in config. As you can see, it is compliant. It does not say resources are non-compliant. Any questions on this demo? All right. I think we can move on to the next topic then. The code for that demo, config demo, we'll be able to provide you later using a GitHub link. Let me quickly go to config. Any questions on any previous topics? This is basically the architecture diagram for our demo, right? So AWS config checks our S3 bucket compliance. An event is generated in CloudWatch. This event then triggers our Lambda function. The Lambda function notifies us of the non-compliant resource and at the same time remediates the resource such that it becomes compliant again. To understand the difference, I would think CloudTrail config and CloudWatch might have some similarities, but they're not the same. So to understand the difference, I've added this slide. Basically, what CrowdTrail will do, it will give us the API level monitoring, right? So which user accessed which resource to perform what action. This is what CloudTrail logs, right? Who made changes and IAM level monitoring, so users, roles, groups, etc. What config does is slightly different, right? It records the configuration level changes, if and only that. So not just calling a particular resource or performing action. If the configuration of a resource is changed, that's what's recorded by AWS config. And while CloudTrail only checks for IAM level permissions, right? If a user is not allowed to perform a specific action, CloudTrail will log it as CloudTrail will log it as not allowed or insufficient permissions. But what config would do is it will check those config level changes against the rules that we have defined, either custom or AWS managed, and it will inform us about the compliance or non-compliance of the given resource against the defined compliance rules. CloudWatch, whereas, is completely different. CloudWatch monitors the performance of various services. It monitors our resources, and it can also log application level logs, right? And like within a application, if you write certain logging statements, they can be seen in CloudWatch. So now, moving on from compliance and audit, we come to external threat management, right? So coming to GuardDuty. What is GuardDuty, right? Amazon GuardDuty is a threat discovery and threat detection service. What does this mean? So what GuardDuty does is this also continuously monitors our AWS environment, but this one checks for something slightly different from AWS config, right? It might overlap a little bit, but what GuardDuty does is, it, with the help of machine learning algorithms, it tries to understand patterns in our logs and detect any malicious actions that are happening within our AWS accounts. It delivers us with detailed security findings of what has happened, and it has like three level of findings, right? A low, medium, and high. Low could be something that is not that common that you do in your account, but it is normal. It is not a threat. Whereas high could be something like someone is mining cryptocurrency in your account. So in that case, it's something that you should immediately look into, right? Unless you're a cryptocurrency mining company, you need to look into that. That's why that's a high type of finding, right? So, what GuardDuty does, it has various origins for logs, right? It monitors VPC flow logs, it monitors CloudTrail logs, and it monitors DNS logs. Now, as you can see, VPC flow logs and DNS are more of networky type of logs, right? By CloudTrail. So, let me give you an example. Let's say someone has gained remote access of your EC2 instance, and now they are using that EC2 instance to make calls to another remote location, right? So how GuardDuty will detect this using these three types of logs is on CloudTrail, GuardDuty can see that this EC2 instance is been accessed from a location, like from an IP address that is not recognized. Then it will check the VPC flow logs, and it can see that now this EC2 instance is making outbound request to another unrecognized IP address. So now these two logs come together here, and GuardDuty was able to find out a pattern that is unusual in your account and notify you about this threat. After GuardDuty has generated any of these three findings, what it does is similar to config, it logs it into a CloudWatch event, right? And we can use a pattern as I demonstrated before to either trigger a Lambda function or an SNS topic to notify the users or to launch a remediation action. Uh, what DNS logs are basically, DNS logs provide us more detailed data about our DNS information, such as sent and received by the DNS server. Uh, and similar, this data is similar to sort of VPC flow logs, uh, and this can be like between two IP addresses as origin and destination. It can be between two ENIs, etc. So as I mentioned before, there are three data sources: VPC flow logs, DNS logs, and CloudTrail events. So this is how GuardDuty findings appear on the AWS console. This is how it would appear on the console, and this is the API or the JSON format. So this can be useful, as I mentioned previously, in attaching a remediation action to that particular resource, right? In a Lambda function, we can reuse this JSON to like do a response action or a remediation action, or we can even send it to another security information and event management tool, a third party tool. So this threat information would consist of the severity, that is either low, medium, or high. It would then contain the region in which this threat has occurred, the frequency in which it has occurred, type of threat, the affected resource or resources, and the information about it. This is viewable via events as well. Yeah, that's pretty much about GuardDuty findings. Let me display it to you on the console. So GuardDuty has a 30-day free trial, and after that it charges you some amount. So you can always go and check the costing for GuardDuty. So if I go to get started, it is pretty simple to enable GuardDuty on your account. You can directly just click on this button and enable GuardDuty. What you can also do is when you enable GuardDuty, you assign it specific permissions to analyze your CloudTrail logs, VPC flow logs, and DNS query. So you need to assign a permission to GuardDuty to be able to read all these logs. And it's as simple as that. Any questions on GuardDuty? These logs don't need to be configured separately. GuardDuty can directly access these event logs in their respective APIs. So GuardDuty was basically about threat and anomaly detection within your AWS account. If something is acting weird, it informs you about it. Next, we come to AWS Firewall Services, or what we call AWS WAF, Web Application Firewall. So, to understand WAF, we need to understand the type of threats that usually come in when we host an application on cloud. There are, in the OSI model, there are two layers where most commonly attacked by threats. One is the application layer, layer 7, and layer 3 and 4, which are the network and the transport layer. So the very famous types of attacks are DDoS attacks. So DDoS attacks can happen in both these layers. So there is, for the application layer, there's an attack called HTTP flood, and transport layer for different types of ports. There is application attacks such as SQL injections or cross-site scripting. Then there are bad bots, crawlers that can attack your system, right? So these are the different type of threats that you need to tackle when you host an application on cloud. So where does WAF come in, right? WAF is a web application firewall that helps you protect your web application on the level 7 or layer 7 of the OSI model, right? On the application layer. So basically, what WAF does is it analyzes all the HTTP or HTTPS requests that are coming in either in your load balancer or your CloudFront distribution or even your API gateway, and it checks them against certain rules or certain control list, web access control lists that will go into much detail further. And if these requests are not in compliance with these rules, then they are denied directly, right? So there are multiple types of rules or options that you can define in WAF. You can count the number of requests that match your criteria. If there are more than a certain number of requests in a given time period, then it could be a potential DDoS attack, right? Or what it can do is block all the requests coming from a certain IP address. You can define an IP list and blacklist those IP addresses. You can also do filtering based on geolocation. You can block requests coming from Europe or from Australia, or you can filter out specific traffic patterns you can using your own custom rules. So there are, again, when it comes to rules, there are two types of rules. There are managed rules that are pre-configured by AWS or third-party tools on the AWS marketplace that cover all the popular use cases of any external exploits or threats coming from outside, right? And then there are custom rules. I can show it to you on the console in just a minute. Let's talk about web access control lists, right? So what are access control lists? They are fine control over your HTTP web requests. So WAF analyzes, like I said, your web requests that are coming in your load balancers or CloudFront distributions. And using this ACS, you can choose how to respond to these requests. Either you can deny a service or you can let them in to access your protected resources. So, based on the request, there will be a particular type of string matching or a regular expression matching that you can do in these access control list. You can check the size of a particular request. You can detect a type of scripting in the request, a type of language that is used, or even the rate at which the requests are coming. Before we get into the use case, let me demonstrate to you what the WAF console looks like. Right. So given the main page, you directly get an option of creating a web ACL, right? So if I go to web ACL, and I can choose a specific region where I want to create an ACL, let's say in Northern Virginia. I can give it a sample name and the CloudWatch metric associated with it. So in this rule, this access control list would create a metric, and every time there's a match, this metric would be 0. Every time there's not a match, it can be 1, or vice versa. Then the resource type. So if it is attached to a CloudFront distribution, if I select this option, you see the page will be refreshed, and instead of working for only Northern Virginia, this rule will now be global, right? Since CloudFront distributions are global. Or if I select the regional resource for load balancers, API gateways, it would again give me an option. It would be now regional, right? It will ask me to select a region where I want to implement this particular ACL. When I click on next, I can add rules here. So as we talked about, there can be two types of rules. There can be managed rules and there can be our own defined rules. So if I want to add a managed rule, we can see here there are multiple managed rules. There are AWS and there are also third-party managed rules that we can attach. They can be free and they can also be paid. So this is a paid rule, bot control, protection against automated bot attacks, right? And these are free rules. So IP reputation list. So this rule would identify specific malicious IPs and they would block it. Similarly, they have multiple use cases covered in all these rules, right? And these are all the third-party rules that are created that we can attach. And we need to subscribe them to in AWS Marketplace. So for now, I haven't attached any rules. So this says here WebACL rule capacity unit. So what capacity unit is basically is WAF identifies capacity units of a particular rule based on how many resources need to be loaded to make that put that rule in action, right? So the higher the capacity unit of your web ACL is, the higher the cost will be. So you can try to minimize the cost of your web ACLs by using and understanding capacity units. Now, what is default action, right? Default action, allow or block. So if you have defined, say, 3 rules here, and your request that comes in does not match any of the rules, you can define a default action. If it doesn't match any rule, then it can be allowed in. So if any request does not match any of the rules defined, they are either by default allowed or they are blocked. So in case of geolocation, if you've added a rule where a request should be in Northern America, right? If I say allow, then all the requests only from Northern America will be allowed in your network. And if I say block, then requests from anywhere but Northern America will be allowed inside your network. So here we can set the rule priority, right? So if I have 3 or 4 rules, we can select which rule takes precedence, right? If a request is coming from Northern America, and if its IP is present in the blocked IP list, then we can choose either if the IP list rule comes first, then that request would be blocked. But if the Northern America rule comes first, then that request would be allowed in our network. Then we can attach CloudWatch metrics as I defined previously. And what are request sampling? So basically here, if we enable request sampling, this would give us the requests in the last 15 minutes that have come in and the rules to which that requests have matched, and if those requests were allowed in or if they were denied. So this helps you understand the effect of the defined web ACL. So yeah, that's how you define a web access control list, right? Here I can also define IP sets. So what IP set is, I can create an IP set and I can add multiple IPs in it. How to use this is this in itself forms an entity, and now I can refer to this IP set when I'm defining my own web ACLs to either block them or to allow them, right? Similarly, we can define some regex pattern sets and reuse them in my web access control lists. And we can also have rule groups, right? A rule group is also a single entity, and I can directly use it in my web access control list. So here in the marketplace, we can see there are multiple rules, right, covering multiple use cases. So any questions so far on WAF?
Yeah, I think there are two questions. One is from Harish. Could you please explain even more about IAM Credential Report, how it functions every time when they are generated continuously?
All right. Yes, I can do that. Let me just navigate back to the slide. Yeah. So in IAM, there's an option to enable this particular IAM credentials report. What this report serves as a function for is it lists all the users in the account and the various credentials that are enabled for the users. For example, if a user has only the console access, then the user would have username password attached to them. But if a user has console as well as programmatic access to AWS, then the user could have multiple access keys, secret keys, as well as a password assigned to them. So it would be very tedious to go inside every user and monitor uh, like how they are, what is their activity pattern, if they're using their access keys or not, if they're using or rotating their passwords or not. That's why we can create IAM credentials report. So these can be created at a given period of time, right? And these are all the details that these reports cover. So for example, for a given, it also covers the root user, right? Root account credentials. So for a given user, say Pam Beasley, when the user was created, if the user's password is enabled. So for example, Pam does not have console access here, only has programmatic access to AWS. That's why she only has access key attached. So, and when was the password last used? So she does not have used the password, right? And if the access keys are active, so she has one access key active and it was last rotated on this particular date. So based on your compliance rules and regulations, given a particular date, you can ask your users to rotate old access keys within a month or within 3 months. And you can also check on the last date when the access key was used. For example, if the last date is given as NA, that means this user, Daryl Philbin, is not using his or her access keys, right? Which means we can ask these users to delete these access keys for security purpose, right? So that they are not accessed by the wrong person. So we can ask this user to delete this security key. Similarly, many projects have this rule that all the users should have MFA enabled for added security, so that not just anyone who has your password can access your account and perform actions as your user. So in that case, we can check if MFA is enabled on a particular account, and if it's not enabled, we can inform these users to enable MFA.
Cool. So thanks, Ashriya. The second question what we have is, can you please explain POSIX Python means? I think this is with respect to the web-based, the firewall, I think.
So is this respect to AWS Managed ACL?
Yes.
Okay. Let me just navigate to that. Okay. So on a high level, right? So there are multiple use cases in which a particular request could be a threat, and it's not possible to know each and every use case, right? But POSIX operating system is a particular type of operating system which is known for carrying out exploitation type requests to multiple applications hosted on cloud. So therefore, there's a rule that says POSIX operating system that detects if the request pattern is associated with a specific to POSIX or POSIX-like OS, right? So this will help prevent attacks that expose file contents or execute code for which access should not be allowed, right? Basically, this rule, what it does is for a given operating system, if it's a POSIX operating system, if your application uses such a operating system, and if there's a request coming in that could have qualities that could exploit this operating system, this rule would block that request.
Yep. Thank you. I think that's what we have so far. We can continue with the presentation.
Okay. Okay, let me navigate back to web. Hmm. So let's try and understand this use case, right? You don't need to pay attention to this architecture, but let's say there are some valid users that are trying to access your application, and there are some attackers or there are some bots that are trying to access your application. All these requests, these HTTPS requests, go through WAF, right? And WAF would check these requests against these following managed rules. So it would check these requests against if it is allowed in the managed rules, if it is in the denied list, if it is lying in any of these managed rules, like if it's an SQL injection type of request, if it is an DDoS attack, HTTP flood is layer 7 DDoS attack, or it is it is coming from an IP address that is blocked, that is said to be malicious, or it is blocked. If WAF finds out the request to be matching to any of these, then it would block that request, and that would help us segregate valid users from attackers. Usually, in DDoS attacks, what happens is there would be an hacking authority that would take remote control over multiple network connected devices, right? They could be IoT devices. And then they would program these devices to act as bots or botnets. That is, they would send requests to a particular application at the same time and overflood it. So, give it a lot of traffic than usual. That would result the application to either become really, really slow, or it would result in the application denying service to the valid users. That's why it's called distributed denial of service attack. It's very hard to identify these attacking bots from the valid users because these are coming from various IoT devices or network connected devices all over the world, right? So you cannot identify these. So the only way you can block these attackers is either using WAF for layer 7, or you could also use AWS Shield. That would be the next service that we are covering after this. So all the requests would first go through WAF, would be logged in an S3 bucket using CloudWatch, and then the allowed request would be going to your resources such as load balancers or CloudFront. Before we move on to Shield though, I'd like to cover a service called AWS Firewall Manager. So it's a really simple thing. It's basically what happens is WAF is defining your rules at a particular account level, right? In a particular account, you define certain rules, and but in case of a larger organization, if you have multiple accounts in your project, what happens is to maintain consistency across all projects, you would have to use AWS Firewall Manager. What it does is basically what you can do with Firewall Manager is you can maintain all the rules centrally in your master or your root account for your AWS organization setup, right? And you can have a common set of security rules as well. So firewall does not only function in helping us maintain a central list of rules for WAF, it would also help us create centralized AWS Shield protections. So it also works with AWS Shield, which we'll be covering in a minute. It can also work with configuring new VPC security groups. So you have multiple VPC in a single account. Imagine having how many VPCs in multiple accounts, right? So it can also help us centrally organize VPC security group rules and check for compliance of them across all these accounts centrally in a master account, right? It can also help us deploy various network firewalls across different accounts and across different VPCs of your organization. And you can also associate VPC with Route 53 DNS rules, like certain rules that Route 53 also can be defined. In Route 53 also we can define, for example, geolocation based rules. So we can also centralize the allocation of these rules using Firewall Manager. Firewall Manager makes it easy to maintain these rules, as well as like in case of AWS organizations, it helps us maintain consistency across all accounts. So here is a use case, right? So in an AWS organization, let's say we have 6 accounts. Using Firewall Manager service and using AWS config, we can monitor the rules that we've set up, right? The central rules that we've set up. We can monitor using config if this configuration is changed anywhere in any of these accounts by aggregated logs from AWS config. And we can also maintain various Route 53 related rules, shield rules, and security group configurations as well. So that's where these two resources can work together and help us maintain security and compliance in all of our accounts in AWS organizations. Firewall Manager also makes it easy. If you create a new account in this organization, it will automatically implement all these rules that we've created on that new account as well. Coming to AWS Shield. So, as you saw on the WAF console, we had an option to configure AWS Shield as well there, right? So, let's talk about Shield. Shield mainly focuses on only one type of attack, that is the denial of service attack. So as you can see here in this diagram, and I explained it before, right? It's basically flooding our server with multiple requests from bots or botnets, that is a group of bots, such that it denies service to the actual users. So what Shield does is, as you see in this diagram previously, one second. Yeah. Now, Shield helps us in managing the type of threats in this box only. But what it does is, since WAF only gives us protection against the application layer, Shield also covers the different attacks that are coming in from the network and the transport layer as well. So TCP floods, UDP floods, the abuse of the SSL port that can be open in your specific instances, or various attacks such as the sync flood attack. Now, if I go to Shield, there are two types of offering that AWS provides on Shield. There is an AWS Shield Standard, and there's an advanced edition that is paid. So standard is simple to set up. It's just one click and you set up Shield, and it is a free service that can be enjoyed by every user. So what standard does is it gives us protection against the most common types of DDoS attacks that occur in the network and the transport layer, and that target your web application. But what Shield Advanced will do is, it first of all, it gives you a response team, right? There's a team of people who would be continuously monitoring your application and working on remediating any loss or any issues or mitigating them. So that's what Shield Advanced comes with. Also, that is called the DDoS response team, right? As I've mentioned there. And it has a higher fees. It protects against higher fees. That is, like, if there's a DDoS attack, obviously there are excessive resource provisioned in your account. If you've enabled auto scaling, your resources would auto scale to their highest capacity, even though no actual users are being served. So that would cause in very high cost in your AWS account. So this team helps us in mitigating these high costs. So finding out DDoS attacks before they happen, right? And they protect against more sophisticated attacks, more hard to detect attacks, which are complicated, on the following services, that is EC2, load balancers, CloudFront, global accelerators, and Route 53. So this team that is called the Shield Response Team or the DDoS Response Team would have an added feature to your application. If it is very critical mission specific application, then you would need a team of like actual human beings who monitor it. That's why Shield Advanced is offered. So here are, like as I mentioned before, the benefits of using Shield Advanced. It has faster mitigation, obviously, because you have a team assigned to you, and it is customized to your application. So use case specific to your application are covered. This team is there 24/7. You get a quarterly security report. You have a dashboard that tells you the global threats. I'll display this dashboard to you in a second. And it has CloudWatch metrics assigned to it. So let me show you the Shield dashboard. If I go to AWS Shield, go global threat dashboard. So this dashboard is only enabled when we use Shield Advanced. As you can see, excuse me, just one second. As you can see here, this dashboard demonstrates the most common sampling of the most significant attacks that AWS is monitoring and mitigating for customers across all of these services, the regions where they're coming from, the events in the last 2 weeks, the largest package transferred, the largest request coming in. All these details we'll be able to see specific to our application when we enable Shield Advanced. So yeah, that's about it on the AWS security services. Are there any questions?
Yep. So yeah, I think we do have questions around from Dora. The question is, can we replace a primary firewall as Amazon Inspector Service? And after that, can we add secondary firewall, WEF?
And that's an interesting question. And I've never tried that personally, but yeah, I think Inspector is more of like its functioning is more of around what GuardDuty does, right? Within AWS, inspecting any anomaly on any resource. But yes, I can come up with a more detailed answer later in the comments. WAF is more of checking out the resources requests that are coming from outside within your network. GuardDuty and Inspector is more of checking the anomalies inside your VPC.
So yeah, I think just to add a point right on that one, Dora, for sure you can have both of them in place, right? As Aishwarya also mentioned, Inspector work closely with your resources internal to it, right? Let's say if you want to scan any binaries or how it operating system works, that kind of stuff. If you need overall a networking layer kind of stuff, like not just a specific, let's say EC2 or ECS, if you need across your entire networking solution wise, then WEF comes into that layer kind of stuff, right? So for sure you can combine to them. You have to be careful in the scope what exactly you're trying to achieve with both of these services. Yeah, I would request for rest of the guys, if you have any further questions, please post your questions on the chat. We have a few more minutes. And in meantime, I want to remind everyone, for the guys who are with us today, please, if you haven't registered so far, you're not part of our bootcamp or have not part of our chat group, please do register. The link is given in the chat for of this registration. It's a simple Google form. You have to just enter a few details, and you will get the link and every other stuff to be part of the chat group. So please do register. This week we had two wonderful sessions from two guests, which was yesterday, it was data analytics. Today we have Ashwarya with us on security part of it. I think both were really good sessions, backed by good hands-on demos. Similarly, we'll come back again with next week with two amazing speakers and a wonderful hands-on learning curve what we'll have in the next upcoming sessions. In the meantime, if you have any other questions, please post on the chat. Awesome. So yeah, I'll remind again for all the people who are actively participating throughout the bootcamp. At the last session of bootcamp, we will reward those people for their active contribution with help of AWS certification vouchers and AWS credit. So please do register with us, participate actively in the chat group, participate in these different sessions, and get certified. Thank you so much for joining today's session. And I'll see you guys next week with wonderful other sessions lined up. Thank you so much. Stay safe. Thank you.